So I know that these three toolpaths are checking out. So I want to continue to rough this part out. I'm going to need to rough this particular bore out still. So I'm going to continue using this create a derived operation 2D milling. And instead of contour to rough that out, I'm going to go ahead and use a boring operation. Now this is a helix bore operation, so it's asking me for cylindrical geometry. Now the cool thing about HSM is that it's picking up the entire cylinder, and I have the option to change the height. Again, this is going to the model bottom that was selected to it, but I have the option to select the whole bottom. Now that automatically selects the end geometry of any cylindrical geometric shape. So therefore I am automatically moving to that location, but it's 0.05 millimeters past, so I'm going to change that to 0. Go into my passes tab and look at my technology for a moment. You can see things have changed. I have the ability to use multiple passes if I need to. In this case, this hole is big enough or small enough for the cutter to where I don't need to do that. I have my pitch control, important to know, so I can change this to be 1 millimeter, or even in this case for aluminum, I can go much bigger than that. I control the value of my helix. And then I can add a finish pass. Now the finish pass is going to be a circular pass with a lead in, lead out, 2 engage cutter compensation, and allow me to use G41, G42 again. This is the finish allowance of the actual step over the finish. We'll go 0.1 millimeters for that. And we'll have 0 stock to leave because we're gonna actually machine that bore all the way down. That's a clearance bore, so this should actually be the perfect tool path for it. And just like that, I've got the proper tool path. Now you'll see there's something wrong with it. I may have actually accidentally selected the wrong compensation value. And there we go. We'll switch that over to where, and you'll see that now that's accurately represented to the tool radius. Hit OK. That bore is completed. And now I need to do just a finish toolpath within this cylinder. Now, I would normally, in most CAM systems, use a contour to come in and just finish this bore. But what I would like to do is actually right-click, create a derived operation, a 2D milling operation, and use a circular cutting operation. Now I'm going to come over here to the panel real quick and show you down in the drop down menu where this toolpath is, and as I hover over it you'll see that this is for circular milling. Now the important thing to recognize with this is it's set up in the post processor to actually create full or separated arcs based upon your machine tool's individual needs in the post processor. This is going to be different from what your machine output's going to do with contours. So it's important to understand that contour shapes are good for just about everything. But when you want a true circle and to create true circular G-code, use a circular toolpath. So we're in our circular toolpath now. I've used a derived operation, so I'm using the same tool. I'm going to select the cylindrical geometry. And you'll see that by default I have this set up for roughing strategy. My heights are going to be controlled by the derived toolpath capability off of that contour. Inside of my technology and my passes tab is where I'm going to change the multiple depths. So I'm going to turn that off. I'm going to just have the individual lead in, lead out. The individual single toolpath at the very bottom. Now in my linking toolpath, I always have lead in, lead out to center selected. This is a personal preference, as I like to see in the G-code before it goes into the hole that it has reached the actual center of the hole before creating the contour. So if I turn this off, you'll see that it will lead in, lead out close to the wall and save some time. For me, when I'm machining most things as a prototype, I like to be able to look up at that position and know that I'm relative from my coordinate system to the starting point of the center of the hole. It's just an extra added check for me. I'm going to hit OK. That's going to finish that bore. Now this is a thread. So While I've finished the ID profile of that thread, let's go ahead and look at our next toolpath, which is actually going to be a thread toolpath. So in threading, this is a thread mill toolpath, and it can do both internal and external bores. I'm going to left click on it. Now we have the toolpath dialog again pop up, and we're going to go ahead and go into a library. Now I'm going to look up a thread mill. So I'm going to go by toolpath type, by tool type. I'm going to left click on thread mill. So I don't have any libraries with any thread mills defined, so I'm going to actually have to make a new toolpath. So I'm going to hover over my toolpath library in this instance. I'm going to make it directly in the library. Go into a new milling toolpath, left click on my cutter type within the general tab, and you'll notice that there is no thread mill option. What I'm actually going to use is a form mill. Now I already have the geometry of my particular thread mill that I like to use created externally. So I'm going to import that geometry. That's simply navigating to wherever that solid file is created. And I'm just going to simply left click on that solid, and it's going to open and import that solid profile. So now I have my 60-degree single point thread mill cutter defined. I'm going to select OK. Again, I could go through and name it. In this case, I'm going to skip that in the savings of time here. I'm going to select that tool. You'll see graphically I have a representation of that tool here. Speeds and feeds automatically populated. I'm not going to worry about that for now. And this is where I select the geometry next, which is going to be that face. Now whatever the default settings are set up to is what it's going to automatically go to here. So I'm going to go to my passes tab. Everything should be set from whole top and whole bottom, which is going to pick up that cylindrical geometry there again. And in my passes tab, I'm going to control what my pitch is. Now in this case, this is a M56 by 2mm thread. So we're going to change our pitch to 2 millimeters. The diameter offset is created if there is a difference in the geometry selected. So if the major diameter is not represented and it is represented by the minor diameter, you may need to change this offset value to create the difference between the whole diameter and the actual diameter of the major diameter of your thread. We'll change our compensation to wear, because naturally every time you thread mill, you're going to have to actually comp it out to make a good thread. My linking tabs, I'm going to go ahead and leave everything default, but you can see that I have the normal selections here, and the one that I'm going to change is the vertical lead in and then out to 0. I'm going to hit OK. Now with the toolpath complete, I want to go ahead and verify that toolpath so that I can see the actual threads. Now what I want to do in this case, I want to see the threads as I cut them. So what I'm going to go ahead and do is come down to our visual styles on our right hand side menu bar here, and I'm going to change it from shaded with edges to wireframe so that now I can see through that part, highlight just that toolpath and simulate it. Now I'm going to turn off stock for this first simulation. I'm going to put it to the left view so that I can see this side edge of my hole. And now I can run the simulation of that part, and I can actually see the engagement as I'm off to the side to see whether or not it's going to create the correct thread on that diameter, as well as tracking and navigating the pitch. Now I've clicked on show points, and the reason for that is that you can actually come to the furthest point at any point in time in the code. You can click on any point to see where that is with any cutter, and I can see from here that I'm engaged into that wall. So now what I'm going to go ahead and do is just to double check and make sure, I'm going to verify all of the toolpaths, and I'm going to show stock. Now what I should see in the stock now is that I have a full cut thread all the way down into my stock. Now you would notice that I have the part set to machine from the bottom up. There again, there is an option in here to machine from the bottom up or the top down, and that can just be changed by simply changing the direction from climb to conventional. Now that that's set to conventional, that's actually going to conventional cut from the top down direction. And as I simulate that, I'll turn the stock off and push play, and you can see now I'm going from the top down.